So we need to understand why it's essential that we have equations being balanced. And you can think a little bit about how we can balance things in everyday examples as well. So if you think about something like a seesaw, which we're all familiar with, so we've got our seesaw, which is a long bar, and we might have say a couple of students sitting on one end of it, and we've got a cardboard box on the other end of it. Now, just to make things interesting, underneath the students I'm going to put a little lake, and it's going to be full of piranhas, hopefully slightly better drawn ones anyway. So if this is not balanced, then potentially our students are going to fall into a lake of piranhas, which might not end well. So let's say each student weighs 50 kilos, so we've got 100 kilos on this end. Now what that means is we must have 100 kilos of stuff in the box for this to be balanced. Now if we don't have that, then our seesaw is going to tip one way or the other. Now the other thing with this is that if I change the system in some way, I've got to match the change on the other end. So let's say we take one of our students away, then what we might then we're going to have an effect there. Oops, didn't quite mean to take my my seesaw away as well, but we're going to have an effect there that we have to balance. Just put my seesaw back. So if I've taken a student away, I no longer have 50 kilos, so I've subtracted 50 from that side. Logically, I have to subtract 50 from this side, so that now the weights are the same and it still works out. Now you can see with equations how they need to be balanced as well, because basically if they are not balanced, then they're not true. And we can have a look back at our previous example where we had 5 boxes of eggs equaling a total of 60 eggs. Now we figured out over here that 12 eggs would go in each box. Now we can check that things actually match up here, because 5 boxes times 12 eggs on one side, and we know that 60 is our total on the other side. 5 times 12 equals 60 down here, which equals 60. So these statements are true, and they must be true at every stage. If we get something happening where we try and say 50 equals 60, well, we know that that's not true, and so our equation isn't balanced and it no longer makes any sense. So whatever we do with equations, we need to do it in a balanced way, which means whatever operation we do, we must do to both sides of the equation. Now that's actually a really important point, so I'm going to write that one down, and I recommend that you add it to your notes. So any operation must be done to both sides of the equation. Okay, sorry, skipped ahead there. Any operation must be done to both sides. Now the next skill that's important is substitution. Now substitution is a really simple thing, and it is just when we replace a variable with a number so we can then calculate the value of an expression. And we did that, I showed you an example of that just before with the eggs, but we can go to another really common example. Our equation from earlier, where the circumference of a circle is 2 pi r. Now, so we're going to calculate the value of this expression by figuring out what this side of the equation equals. And the way we'll do that is we need to know an r value, so a question would need to tell you something like that, so we'll say 10 centimeters. Now this is saying 2 times pi, which is just a number, but we generally write the pi symbol. I'll just say 3.14, although it has an infinite number of decimals. And so to find the value of c, so calculating the value of this expression, is just 2 times 3.14 times the value of r. Now I recommend that when you're showing substitution, you put the value in brackets first, because sometimes it will make it easier for you to understand what the next step in the calculation is. In this case, the brackets don't really do anything though, so effectively all we're doing on our calculators is just this times this times this, and in this case I end up with 62.8 centimeters because that's the unit of what we're measuring. Now, another thing that's important is the order of operations, and the order of operations is telling you literally the order that you do stuff in. And when we're evaluating expressions, so what I mean by that is when we're calculating the value or the numerical answer for an expression, we have to do it this way. So what we do first is stuff in brackets, then we do it's BODMAS, so order, which basically means exponents or indices. Then we do division or multiplication. Now, these are actually, they're equivalent to each other, so it doesn't matter which order you do these in. I think they're only written this way because otherwise it'd be really hard to make an acronym with BOMDSA. And so, yeah, they've written it this way to make it sound cooler. But division and multiplication, these two are equivalent, so it doesn't matter which order you do them in, they're the same. Now, lastly, addition and subtraction. Again, they're equivalent to each other, and the order is not important as long as they're done last compared to all the other ones. Now, what do I mean by this? Well, let's go to an example. No, my bad, wrong page. So let's make up an example then. Now this might be a kind of complicated one. Say y equals, because I want to put a bunch of things in here, equals, well, I'm going to put a bit of everything in here really. X plus 3 squared, now I'll multiply all that by 2, minus 7. Now, if x equals 3, say, now the first thing we can do in a case like this is we're going to substitute. So I'm going to replace my x with 3. So y equals 2 times 3 plus 3 squared minus 7. Now this is where we've got to think about our order of operations. So what have we got? First thing we've got is some brackets. So the first thing I'm going to do is think about what's in the brackets. Now when you're in the brackets, you've still got to think about what your order of operations is. Now all I've got on the brackets is addition, so that's all I need to do. Now the way I really recommend you work through these is to show each step. So I'm doing one operation and then I'll write the equation out again in the simplified form. So nothing's happened to the 2. 3 plus 3 is 6. Squared minus 7. Now I go to my next thing. Now I've sorted out my brackets. Now all I've got left here is one thing in the brackets, so there's nothing else to actually happen in the brackets. My next operation is the exponent. So I've got 6 to the power of 2, which is 36. Then my next operation is that I've got multiplication, because I've got 2 times 36. So that will happen before I do the subtraction. So 2 times 36 is 72, minus 7, and so my final answer is y equals 65. Now, you don't really need to write y in a simple case like this, because the equal sign is saying that this stuff here equals this stuff here, equals this stuff here, and so on. And so at any stage in this equation, these things are all equal to each other. Later on there will be some examples where you'll always write the expressions on both sides of the equal sign. But for simple ones where there's only one term on the on one side of the equal sign, I'm not worried if you miss it occasionally. Now, when we're solving equations, we are trying to find the value of a pronumeral. Now, that is slightly different to what I just did there, although sometimes in certain examples, it will be exactly what we just did. Really, all we'll do is substitute some stuff, and then we'll be able to do a calculation to evaluate everything, and that's that. But sometimes we have to rearrange the equation to get the pronumeral on its own. And when we're doing this, we actually do the order of operations in reverse. So rather than doing brackets first, I'm actually going to do addition and subtraction first, and then I look at my division and multiplication and so on until I get to the brackets as the last thing that I would do. Now, because we're doing linear equations as well, we're not going to do much with indices at all. Later on, if you get through all the linear stuff, then you'll start to look at some equations involving indices, and that's a little bit more complicated. And also, you might remember from when our work on algebra earlier in the year, we started doing some double bracket things where you were getting x squared and that sort of thing. Those types of equations are not linear, but you've already come across them a little bit, so some of it will be familiar.